on the progress check. So, I mean, it was, of the 7 who submitted, when I checked recently, 5 of us missed this one. So, yeah, okay. So, here's the thing that I need us to pay attention to. First things first.
Bro, you're gonna open that.
Oh. So, what does it tell us from the beginning here? These events are what? Independent. So when I look at this statement, what should we immediately what should I immediately think when I look at this if those two things are independent?
It equals to probability.
Probability of A. Is that the probability of A? No. Right? So I immediately know that that one's wrong. Same thing with B here. That should equal the probability of B. Great job, right? But the probability of B, let me just write this. Probability of B was 0.5. Probability of A was 0.3. Nope. Yep, okay. So that one's backwards. What should this equal again? 0.3, right? The probability of A, which is 0.3. So that one's out. And so now we're looking at just D and E. And so we're looking at D and E. What formula should we immediately think about? General addition, right?
Oh my god.
And remember, this is on your formula sheet. When I see that union, look at your formula sheet.
Probability of A plus probability of B minus probability of A and B.
Okay.
What is the general multiplication?
So, probability of
I
A.
don't know. 3.3.
There we go. Probability of B.
Wait, where's the
5.
Now, how in the world am I supposed to find this intersection?
No way, I don't make it.
Isn't that what you multiply?
Well, what kind of events do we have?
Independent.
Wow, Sabrina! These are independent!
So you
Right.
So you just have to
So if they're independent, that's just the probability of A times probability of B.
Which one's that? Like, what rule is that?
General
So,
I don't like the
Okay,
name.
I'm gonna grab that.
listen, general just means it always works. This is always true if they're mutually exclusive, or Braden, what's the other word for mutually exclusive?
Disjoint. No.
Disjoint.
Yeah, disjoint, yeah.
This is 0, so you can ignore it, right? The general addition, it always works. But we need to recognize here, hey, I need that intersection, and there's one place that we always have an intersection. It's in the conditional probability. But we should also know that if they are independent events, right? If they're independent, I can just multiply these two things. And so that's all we had to do to find that intersection, which is 0.8 minus 0.15 or 0.65. This question has shown up several times on the AP exam. I first came in contact with it the second year I ever taught AP Stats. And I have remembered it since because I missed it then as well. So I get it. Like legitimately, I need y'all to hear me on this. The first time I ever saw this question, I missed it. And then when I learned that, I was like, dang it, that makes so much sense. You just have to know union. So you're adding and then subtracting the intersection. They're independent, so you can just multiply their two probabilities to find that intersection. Questions?
Wait, how can you tell if something's mutually exclusive again? Like, how can you
Probability of
explain
them
it?
happening together equals 0.
Right, so
I know
if
there's like no intersection, but like.
there is no intersection, the probability of the intersection is 0, but they would have had to tell you that.
So probability of A
and B is equal to 0.
Okay,
Right.
got you.
Yep.
Okay.
Yep. So it cannot happen, so their intersection is 0. All right, so right here. Now, this, number 2, gave quite a few of us a little bit of trouble as well. I don't remember if it was 4 or 5 of us missed this one, but I need us to...
6.
Huh?
I thought it was like really high.
Maybe it was 6 on this one. It was a lot of us.
Exactly.
Regardless, though,
Almost half.
I see a whole lot going on here. And so I'm going to start from the beginning. Actually, I might not start from the beginning. I'm actually going to start and notice this word and this word. Why?
Or and union intersection.
So unions, so probability of late or overbooked. Nope, not overbooked. Pay attention to those underlined words. What do I know that that is equal to?
0.72.
0.72. And they want me to find the probability of late and not overbooked. Well, is there a formula or anything that relates a union to an intersection?
General addition.
The general addition rule again. And so when I look at unions and intersections, we need to recognize that one, we're given that formula. We need to be able to recognize a union though. And so this 0.72 is the probability of late plus the probability of not overbooked minus the probability of the what?
The intersection.
Intersection. Do we know what the probability of being late is?
0.6.
How'd you get that?
0.25 plus 0. Whatever it was.
So they're on time 25% of the time, right? They're early 15% of the time.
That's 40.
So-
To 40, yeah.
That's 40%, so what's late? 60%. So probability of late is 0.6.
Could you do like a tree diagram?
I wouldn't, because these aren't sequential events and there's no conditional probabilities, right? And I will say this, maybe.
Because I think I tried to do that.
Yeah, I don't think so. I'm seeing this or and this and so I will say this, if I'm seeing a union, I'm first going to start out with this general addition rule, and off of that, if I can answer this, then I'm going to fill in everything I can. Maybe if I can't, then I go to a tree diagram. But I can fill all this in, right? Probability of late is 0.6. What's the probability of it not being overbooked?
0.35.
Yeah, probability of it being overbooked, right, is 65%. So 35% that it's not overbooked minus the probability of their intersection. And when I do that, what does it have to equal again?
The intersection. Wait, the. Oh
The
my god.
union?
Whatever.
At 0.72. And that's just solving that equation.
What's
So 0.72 is equal to 0.95 minus the probability of the intersection. And so you can just think through it logically, like what would I need to subtract from this to get 0.72? 0.23. Or you can use the rest of your algebra to solve.
Wait, why would it be?
Why would what would be what?
I don't know how to say this. So there's only two outcomes if it's overbooked and not overbooked, right?
Right.
So how would there be an intersection? Like if it's overbooked and
Well, no. So there's, and so I guess if you want to think about it like this, I wouldn't, but you could think about it as late on time and early. And off of each of those, we are looking at overbooked
Oh, okay.
or not overbooked. At least to help you visualize it. I wouldn't use this to actually do the problem, but that's what's happening, right? And what we want is late and not overbooked. So this is what we want, but we're using the union formula because we have the union. Okay, so help explain that. Okay, so remember, if you got a union, use that general addition formula somehow. Questions?
What's the general multiplication thing?
Yeah, remember it's just built off of the conditional probability. So probability of A given B is equal to the probability of A and B divided by the probability of B. If I multiply both sides of the probability of B, see how we're multiplying there, Serena? So probability of A given B times the probability of B is equal to the probability of their intersection. So general addition is union, general multiplication is intersection, right? But remember, if they're independent, what is this equal to?
Just P of A.
Right. That's how we got that independent
Oh.
multiplication rule.
That makes sense. Okay.
Okay. Question 6 and 14 are the last two. So Andromeda claims the distribution of X is skewed to the right with a mean equal to 4 movies. Is Andromeda's claim supported by the table? So this one is a more difficult one a lot of times for students. How could I check to see roughly what the mean is? Actually, what was happening in this table?
Cumulative.
Yeah, we need to recognize this is cumulative. And so that definitely causes difficulty for a lot of students. And so if you want to make your life easy, it makes sense to break it down. So probability over here, I think 0.1, 0.2. I don't think it goes higher than that, we'll see. And then we've got 1, 2, 3, 4, 5, 6, 7. Don't forget, like, creating a new, so 1, how do we know, by the way, that's cumulative?
Because
It adds up to 1.
and it adds up to.
So 1, I do like that, you notice that it's adding up to 1, right? But it also tells you at the top of that table.
Who actually reads that?
That might be important, right here. Doesn't it usually say the probability that X equals a value?
Yes.
So the fact that it says less than or equal to means it's accumulating. Yeah. Okay, so I'm just separating it out. And it just keeps adding 0.1 each time. So we can clearly see now it's skewed to the right. Where's my median going to be?
Around 3-ish.
No, me too.
Oh, median.
Median. Yeah, so median would be here because it's the 50th percentile, right?
Yeah.
There's 50% right there. And so the mean is probably just going to be pulled a little bit to the right. If you meant mean, I would agree, somewhere around 3. What's up, Chris? All right.
It's over there.
So don't forget to pay attention to that, details. So skew to the right with a mean less than 4 movies. Last one I wanted to look at. This one causes students trouble all the time, and I knew it took me a hot second to realize what was happening the first time I looked at this question. So Serena, what do we know? Do you remember? Can't read it? Can you make it bigger? Yeah, it's almost too big.
Oh, they're going up by, whatever.
It's doubling, tripling, and then it quadruples to get to here. It doubles, it triples, and then it quadruples. So does it matter if it's y equals 1 or 2 or 3 or 4? So those events are what? Independent. Now, if you didn't like that, because I didn't like looking at the table this way either, did you take the time to say probability of y equal, was the first y 1? Y equals 1 given x equals 1? So probability of their intersection divided by the condition. So probability that y equals 1 and x equals 1 is 0.04. Divided by, what's the probability that x equals 1?
0.04.
X equals 1? It's probably that x equals 1.
You add all those up.
Oh, what the freak.
See that now? So 0.1, so that gives me 0.4. Now, and I'll point out why I did that in a second, but you know what that equals? Something. What's 0.04 plus 0.08? 0.12 plus 0.12 plus 0.24 plus 0.16 is?
0.4.
Oh my gosh, because what is it asking about? If x and y are what?
Independent.
Guys, how do we check independence? The probability that y equals 1 given x equals 1 should equal the probability that y is equal to 1. So why did I check it that way? Because it's asking about independence. If they're independent events, I look at the conditional and I look to see if it equals this. Okay?
Yeah,
So-
this is not right.
Huh?
I hope this is not a question.
Well, that's not what we're focused on this part right now, but we needed to learn that before our test later this week. So, but you need to remember independence, right? That's the idea of independence. If the probability of A given B equals the probability of A, they're independent events. As soon as I see a question about independence in the answer choices, that's what I'm thinking about. All right, I need you to clear your desk. Well, I'll say this. I can guarantee you, if you did your progress check, 3 or 4 of these, you're going to laugh because of how easy they are. Nope, you're not. So, clear your desk except for your calculator and your formula sheet. You're allowed both of those. Oh no, Jaden. Paper down.
You're so mean.
Who's me? Not that's on here.
I thought the conditional or like combining them.
That's not on here.
Oh, for real?
Yeah. You better run like the wind. 20 to maybe 25 minutes.
Yeah, I thought
Yeah, I'm turning the lights on in a second. Your what? Is now flashing red? Perfect. So we're just going to do a little bit of practice with it. So remember what we ended with 6.4 is right. This foundation. Hold on. Right here. Determine the mean of a distribution that results from adding or subtracting 2 random variables, and the standard deviation of a distribution that results from adding or subtracting 2 random variables. So we're going to look at that right now. This next part is the very next set of stuff we'll go into. But within this, oh yeah, I'm going to post solutions on that so you can check yourself. Can you go ahead and give everybody this? So what Ms. Kowalski is about to pass out, or is passing out, is a couple of AP free response questions from the past that deal with combining random variables for one of them, and the other one is discrete random variables for the other. So I will say, we're not doing it right now. Do it tonight for me for homework so that you get practice with those ideas, and we'll go over it tomorrow. We'll go over this tomorrow. Okay, so this is where we ended last week, right? So we originally had 2 different random variables, x, which was your pay, I think, right? And y was the, and this is the one I just handed you, Lana. The y was your raise, possibly?
Yes.
And we found some important principles by the end of this. So first off, what were the possible pay at the end of the year? What were our pays here?
10, 12, 13, 15, 16, 18.
Okay, and then what were those probabilities?
0.21, 0.09, 0.315, 0.135,
0.175, 0.075.
You guys sound like a robot.
Alright,
Some monetary
and
waste
so
over there.
Almost insane.
all that to say, so we can easily go in and find our mean, standard deviation, and variance. The most important part was we found out that the mean of this n right here that came from adding those 2 random variables, how could we have simply calculated the mean of n?
The mean of both the variables.
So the mean of x
That's the mean of
plus
y.
the mean of y.
W.
Right? So you just add the 2 means together when you have 2 random variables. How about the standard deviation? Could we just add the standard deviation of x plus the standard deviation of y?
We have to do the variance.
Had to do the variances. So we can add their variances. And so remember, Serena, you were asking, why do we need variance? This is why, right? So I can't just add the standard deviations. I have to take the square root of the sum of their variances. Does anyone remember what I told you to help this kind of sink in and stick?
Pythagorean theorem.
That is the Pythagorean theorem, right? There's this idea that the Pythagorean theorem is at play when you have 2 random variables like that, and it does play when you have more random variables. And so, we got to here, combining random variables, quick notes. So first things first, and I do want to address this. Let's say, I had it written out as x plus y, I think. Well, I'll check in a second. I had it pulled up. But let's say I have two, no, we'll just say t for total is equal to x plus y. We need to recognize that, oh no, that's what I'll do. The mean of x plus y, notice how that's just the sum of the two random variables. How can I find the mean of x plus y? Mean of x plus the mean of y. Okay? So what's that going to look like if I need the mean? So I'm going to put x plus y over here. What if I need the mean of x minus the mean, or minus y?
Don't you just add them again? I don't know, I saw something that was like, where you always add them.
It was something in the textbook.
I don't know, it's like, it's still like addition or something.
Nope.
Oh, never
You just
mind.
subtract means.
Okay, I saw it. Guys, I saw it on the textbook.
I know what you're talking about. We're about to get there in a
I saw it in
second.
the
But
textbook.
logically, right? I'm just going to subtract the means. Okay.
Logical fallacy.
Wait, so what was our reading then?
Nothing, you're literate.
So what's
Guys,
the variance
it
of
was
x
like-
plus
even if it was
y?
like negative.
Oh,
still
yeah,
add
yeah.
everything.
So what's the variance of x plus y?
No, this is
Oh wait,
Can you hold this down?
standard
variant.
The variance of
deviation.
x plus variance of y.
Yeah, watch out.
Just let me do it.
And so the standard deviation
The square root.
is just the square root of those two.
Because it used to be a necklace.
Now, you can memorize this formula, or you just remember, hey, I'm going to add my variances together, and write that, and then take the square root. That to me is the easier. So, what about the variance of x minus y? So remember, when I say x minus y, these are those capital letters. These are the random variables. What about the variance of x minus y?
Is that the one where you add?
Maybe? Is there a reason why it might make sense that we would end up adding here?
Pythagorean theorem.
Pythagorean theorem! That might
Okay,
be
so
part of
I
it.
wasn't crazy. So
Yeah,
that
no,
was the
you're not
one.
crazy. That's
So that was
100%
the one.
accurate. That's what I was looking for. Just make sure. So yeah, it's going to still be a sum. Right, so I'm going to add the variances. The other thing I want you to think about is this. For those of y'all who took AP Chem, entropy only what?
Increases.
Only increases, right?
You did not
Because-
take AP Chem.
Please do not remind
Because
me.
what is entropy? It is a
It's
measure
random.
of,
It's
it's randomness,
It's
right?
random.
It's randomness. So this standard deviation, this idea of spread or chaos or randomness is only going to what?
Increase.
Increase, right? So even though we're subtracting the random variables, you still add the variances. Based on the idea of Pythagorean theorem, you're still going to add the two variances.
Isn't that like the second law of thermodynamics?
Ah,
Like,
Yeah, that's
energy
it.
always
That's it.
increases.
The energy,
Yeah.
chaos, whatever.
Yeah, when
I forgot that was
energy
called
is
entropy,
transferred, like,
Can't go
something
You
on.
literally
is lost,
This is like
which
part
is
one of
why
your mom's
entropy
thermodynamics
increases.
class.
Oh,
You grade the papers or
Love
So-
that, I like that law. That's interesting.
Entropy, anyways, I mean entropy in general is interesting. So, but
So
we need to
anyways.
recognize that if I'm just adding two random variables together, hey, I'm just going to add their means. I'm not going to add their standard deviations, I have to add their variances. If I'm subtracting two random variables, I'm going to subtract their means. But what am I going to do with their variances?
Why are you still adding them though?
So 2 reasons. 1, I still need the Pythagorean theorem. And c squared is equal to a squared plus b squared, right?
So why does it work?
Well, the second part of it is what I was just talking about is chaos, randomness, only what?
Increase.
Increases.
Okay.
So if I take two distributions and I put them together, yeah, I'm subtracting x and y, but I'm still going to increase that spread. That randomness is still going to increase.
Oh, that makes sense.
Yeah. Okay. But again, and so it's tying both those ideas together. That's the best way I can explain it. I could try to see if there's another explanation, but the best way to say it is that chaos is how I like to describe it. That standard deviation, that spread is only going to increase
What was
by putting
enthalpy
two
again?
different things together.
Sprig, what was enthalpy? I knew entropy. I forgot enthalpy.
Do not ask me about anything Kim.
Okay.
Do not ask me about anything Kim.
So the last thing that we want to address is this, because this is actually going to show up basically for the rest of what we deal with is normal distributions. Well, let's say 2 independent normal distributions. And so what I will say is this, do note you can only use these rules if the distributions are what? Independent, they have to be independent. And so what we're gonna be able to do though is if I have two independent normal distributions, if I put them together, either by doing x plus y or x minus y, you know what kind of distribution I'm gonna get?
Normal?
I'm still gonna get a normal. And so all those rules we've learned about with normal distributions to find probability, to find the area under the curve, are still gonna play out. And so when we're dealing with two independent normal distributions, the combination, right, so because I'm combining, because I'm combining two random variables, the combination is also normal. Use those rules to find what?
Mean,
The mean and
standard deviation.
mean and standard deviation. And from that, it's just working with normal distributions as you always have.
Is that why like the whole EYE was like?
Some normal distribution questions, yep.
Oh yeah, I like that.
Yeah, I like that too, it made me happy.
It's also a throwback, right? So work with normal distributions as normal.
Jane loves throwbacks. Him on the, oh.
Let's stop there. It was nice and sweet, and then I was like, no, Serena's gonna take it some weird way. Alright, so please understand the combination of those random variables is also gonna be normal. Use those rules to find the mean and your standard deviation, and then work with the normal distribution as normal. Or I should probably say as usual. As typical, just because that word normal means
Oh
a specific thing.
God.
Oh my god.
There you go.
Looks like
It's not
Like
that
fun.
easy.
I know, but I feel like you get
It was
a little
never
bit
that
deep.
easy.
Huh?
You gotta reach back and go.
Yes.
Okay.
Okay.
Thanks, girl.
So from there, what I want y'all to do is I want you to work A through C here. I'm gonna give y'all, I'm gonna say 6 minutes to work through these three parts. A lot of this is pretty straightforward once we finish reading the context, let's say it that way. So most sports fans believe in home field advantage, the idea that the home teams have a slight edge over the away teams because they have wild fans cheering for them. Let's investigate by looking at the results from all 85 games of a recent NFL football season. Let X equal the number of points scored by the home team, which can be approximated by a normal distribution. Please note, does that look super normal?
No.
No. It only has to be approximately normal. True normality does not exist in the real world. We're just going to say it's approximately normal. And it has this mean and this standard deviation, and Y, right here, is the number of points scored by the away team, which can be approximated by a normal distribution with that mean and that standard deviation. And so now, let's go to our vertical surfaces. Let's work quickly on finding calculating and interpreting the mean, calculating the standard deviation, and then working through this last piece. We got 6 minutes.
Wait, why are we combining?
certain scores. That's why it's not normal.
Say again.
It would be very hard to get certain scores.
It is much easier to get low scores than
I think-
really high scores.
With the point system in football.
Oh yeah, that's why we have gaps in there, 100%.
Oh, yeah. But they got, well, they got the whiteboard.
Yeah, y'all can work over that on that. Pressure on the chalkboard.
After he moved them, so they don't fall. and they
Hey, let's get going. Focusing on the stat side of things. Correctly. We all calculated it correctly. But 9s, which were the 4s, what detail did y'all talk about that no one else has up here?
In the long run. Bro, that's what
Yeah.
I said. That's what I said. We talked about it.
You just said, oh, you did edit. Wow, that is not their original. That's my bad.
I put it in the middle of writing that.
Okay. Oh, my bad. All I saw was this. I corrected myself. My bad. Hey, regardless, I need us to recognize. So please make sure and hear me on this. So you need to say something like in the long run, which means there was somebody I was talking about with this from the progress check. That means that we need to include something like in many random samples, in the long run, something like that. You have to indicate with any kind of probability that we're talking about in the long run. So not the mean number of points.
It's up there. Yeah, we
Where?
said disregard that. In
Where?
the long run. Hey.
The difference between the mean number of points for the home and away team is 2.08 in many
Whatever.
random samples, or in the long run with many random samples. But I will say that, you do want something about in many random samples. The next thing I do want to point out is I do want to encourage y'all to look at what the fours did over there, where they actually wrote out d equals x minus y, and wrote out the mean of the difference is equal to the mean of x minus the mean of y. I would have heavily done that. A lot of y'all wrote some work, but this is clear evidence of understanding. And then it helps us also remember, hey, I'm just going to add my variances, right? Think through those ideas. Now, so when you were asking about formulas, they're not going to give you, ooh, wait a second. Can I see that formula sheet?
I realized. Cacophony.
Well,
Cacophony, what?
Does that work?
epiphany is probably what you meant to say. It's kind of on here, but not really.
Wait,
No,
that
definitely
is a
not.
word, though. That is a word.
Cacophony is a word, but it's about sound being harsh to the ears.
That is not.
Yeah, it is.
It can be nice sounds too.
Cacophony.
That's
No.
a symphony.
Like the cacophony of.
I'll Google it later. Right now I got stats to teach. But variance, right, of the difference is equal to the sum of those variances. And so we should have taken the square root. And I did point this out to one group. There's 9.3 and 9.41. I would have written this out, but I would have just typed this whole thing into my calculator all at once. I would not do multiple steps there. As long as you have the formula, everything substituted in, and then the final answer, you're good. Yes, Jaden?
Why would it be in the long run when you have like all the data points?
Because that's the average if I repeatedly sample one from here and one from here, one from here and one from here. So it's not one sample, it's many samples.
Oh, why do you need a sample when you have all the points? You don't
Well, okay, so
So it's more like a census?
because, no, it's because this is dealing with a random variable. So anytime we're dealing with random variables, we're dealing with probability, and it's not just finding the difference of these two things. That is how we calculate the mean of this difference, but if that was what we were doing, then I would just take the standard deviation of this and subtract the standard deviation of this, but that's not what I'm doing. I'm creating a random variable distribution. So putting these two things together. So, well, and I guess I should also explain this. The idea of the probability distribution here is I take this data value and subtract this from it, and this from it, and this from it, and this from it, and this from it. Through all those. Take this data value and I subtract this, subtract this. So it is literally like every possible combination of here minus every single one here. So that's what makes it that random variable, is all those different combinations. Okay? But that's why, and you have to do in the long run. But we gotta continue. Final detail. Please notice we randomly choose a game and record the number of points. This kind of question shows up a lot, and what we want is x to be greater than y, right? And I showed most groups this, but what does this imply? What's an alternate way to say this?
They win.
The difference
Difference of x more
is greater than
zero.
0. And it's complicated when you have two random variables, but that is literally what we've just done, is find the difference and find the mean and the standard deviation. So it just becomes a normal distribution with a mean of 2.08. And what was the standard deviation? 13 point something?
It's really big.
It's for every bio.
Can't you just
And that's what I'm about. And so this is why I do z-scores, so that we can standardize it. That 0 though would be roughly here. So notice, yeah, trying to mark the actual mean and standard deviation, that'd be a pain in the butt. Standardize that crap. And so, did anyone find that z-score?
I got negative 0.1570.
What's the doing there?
And so, you would just find the probability that z is greater than that. And so, use your calculator, find it greater than, and what does that probability come out to be?
We said 0.56.
That sounds right.
0.562456.
Yeah, so that probability is 0.5624. It's close enough. Yeah, that's what I got. All right, we got to continue. So will the US win the World Cup? That's what we're on. We're on
Yes.
6.5. And we gotta move. Okay, we gotta move because we gotta finish
Did you give
this
us-
I
entire.
don't think you gave us this.
I gave it to you right now.
Oh. Hey, gaslighter.
Yeah.
We will win, bros.
Yes, ma'am. Okay.
It's a women's soccer team. Oh, wait.
Hey, we got 2 lessons that tie into this one. So I'm going to move quicker through this one so that we can get to the more practice-oriented one tomorrow. Because we really do need to finish this up and do a DYU on Wednesday, testing Thursday, projects. By the way, if you want to, and I think that's probably what we would want to do, projects on Friday, we can present during third block before lunch so you can get on out of here.
No, they're making
Thank
us.
you so much.
AP Bob's making us go to school.
Yeah,
Just
we have
kidding.
Mr. Mac.
We have AP.
Nah, we're chilling, just don't show up.
No.
Okay, well, can I just present my part of the
Hey
project?
there.
We have
Hey,
AP.
Are you gonna
if
say?
that's how it is, that's how it is.
Oh my
So,
God.
right here,
no.
the U.S. women's soccer team is doing some calculations to help prepare for the upcoming World Cup. They're convinced that the toughest matches are likely to end in a tie, which is fair based on data. So these matches require a shootout to break the tie, where each team gets 5 penalty kicks. They believe that they will need to make 4 or more penalty kicks to win. So over the history of the World Cup, about 70% of penalty kicks in a shootout are made. Let's assume this is the probability for each of the players on the U.S. team and that each kick is independent. Please understand that this is going to be important. The probability has to be the... Probability has to be what?
Independent. Independent.
Something.
Same
Bruh.
and independent. You are correct on independent. So we need those probabilities to stay the same. They need to be independent for what we're about to discuss. So what is the probability that the team will make all 5 penalty kicks? Well, what's the probability of making the first one? 0.7. The second one?
0.7.
Third?
0.7.
Alright, so same as 0.7 to the 5th. Someone tell me what that would be? Because I have no clue.
So you aren't smart.
You do it, you're.
Yeah, good math.
And it's 0.49 times 0.49 times 0.7. So 0.353 times 0.49.
0.1804.
No, 343.
Oh wait.
Got
3.1.
0.1.
Oh, wait.
You're gonna get it wrong, it's wrong.
0. Point what?
168.
Yeah, 16807.
807.
Yes.
So we'll go 4 decimal places typically for probability, and we'll round it there. Does that one make sense? They're independent events. We just multiply those 5 different probabilities. Now, here's the thing though. How many do we actually need them to make? 4. They're thinking 4 or more, I should say that. So that 0.1681. So I should say this. One thing to keep in mind is that means we are looking for the probability that they make 4 or how many? 5. Now, can you make 4 and 5 at the same time? No, you make 4 or you make 5. So these events are
Disjoint.
disjoint, mutually exclusive. So all I got to do is find what 4 is and add that to the probability that they make 5. Well, we already found 5. Now we got to find 4. So that could happen this way. Make the first, make the second, make the third, make the fourth, and miss the fifth. And these are independent events. So Lana, what's the probability they make the first one? 0.7. Michael, what's the probability they make the second one?
0.7.
All right. Peter? Braden?
0.7.
And then Jaden?
0.3.
Ah, we're missing that last one, aren't we?
Last try, did he?
Nope. I was confident that you did it right, but please don't ever again. So, how could I write this here?
0.7 to the 4th power.
0.7 to the 4th times 0.3 to the first. There's 4 0.7s being multiplied. There's 1.3. So what does that probability come out to be? 0.072. One more decimal, please.
0.
Oh, okay, perfect. Okay, now here's the thing, and this is where it gets important that y'all lock in and pay attention to this. Okay? They want to make how many?
4 out of 5.
4 out of 5, right?
Or more.
Or more. But in this, so the case we're looking at, we want to make 4. Is the only way to make 4 that they make, and then miss?
No.
They can
How else could it happen?
Miss.
So they could let.
Make, miss.
I'm gonna do this methodically in the sense that I'm gonna just kind of walk it back. Make,
It's a lot.
miss,
Make,
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 miss, make,
And
make.
then he's gonna like circle it and then be like
Wow.
whatever and then whatever.
So,
And then it's over.
notice,
Let's
alright? We'll just name another way to make exactly 4 penalty kicks, then find that probability. So, we did that. Now, let's look at this one here. That's going to be 0.7, 0.7, 0.7, 0.3, and 0.7, right? Because I made my miss on the 4th one, not the 5th one this time. Well, how's that going to be written here?
The same.
The same.
Same.
It's still 0.7 to the 4th. It's still 0.3 to the 1st. So that probability is still 0.0720. So what do we notice about those probabilities?
They're identical.
They're the same. They're identical, right?
Why are you laughing?
Okay.
Oh.
So I kind of skipped ahead a little bit. But how many different ways are there to get exactly 4 of 5 made?
5.
5. We can list it out, right? We can see it.
Is there a quicker way to do that? Figure that out.
Man, that'd be awesome, wouldn't it?
Yeah.
Wouldn't that be great?
Yeah.
Wouldn't that be great? Okay. So first things first, I do want to point this out. So there are 5 different ways. So 5 ways to do this. So what is the probability that the team will score exactly 4 of the penalty kicks?
0.0720.
No.
I don't
0.0720 times 5.
I would say, so I could add them all together, but what would be easier?
Times 5.
Just times 5. They're all the same. So 5 times 0.0720. So remember, the idea of multiplication is repeated addition. So to make my life easier, I'm just going to multiply that 0.0720 by 5.
Serena wrote poop on my page, man.
0.36.
She's such a nice person.
So
Saying
mature.
I stink and writing poop on
So
my
0.36. Now, you asked the right question though, Braden. Isn't there an easier way?
Calculated.
So there's 2 easier ways. I'm going to show you the harder of those easier ways first.
Why
Here's
can't
the
you
harder.
show us the easy way?
Just in
In
case you forget.
Choose R.
Oh, I
No,
saw
no,
it.
Wait, I've seen
It's
this
on the
before.
textbook.
I've seen this before.
Combinations. This is a mathematical thing. Okay, so pause for a second. It's okay. So what N is my number of trials.
Oh my god.
R is my number of successes. So I think if you actually look at your formula sheet, it says X instead of R maybe?
Bruh.
Yeah, it says N choose X.
Where's this at?
Oh, the binomial distribution.
There you go. So what type of distribution are we dealing with? You just said binomial! Okay, so if you look under binomial, there is literally a formula there. N
Where's
choose.
binomial?
Well, it's right underneath the discrete that we've been dealing with.
Oh!
Oh, there we go. Notice how it says P to the X. What does P stand for, you think?
Probability.
Probability of...
Distribution.
Random variable.
X.
It's what you want, so we're going to call it the success. So the probability of success. Notice what's 1 minus P then?
Probability of
Failure.
variable.
So probability of success, failure, right? So probability of success to the 4th, because that's how many successes we want. Probability of failure to the number of failures. That's where probability of success to the number of successes times the probability of failure. I think it says N minus X, doesn't it?
Yes.
Because if I take my number of
5
trials
minus 4.
and take away my successes, I'm left with my failures. Now, in choose X here, this is a formula, and guess what? You're never gonna have to worry about this formula.
Yeah.
That's the good news, okay? There is a formula for this. N choose factorial
That was just.
divided by N minus X factorial
Just an announcement.
times X factorial. And it's hideous. How about you all hit menu for me though real quick?
Oh my god, oh my god.
Oh my god, oh my god.
That's not what I said.
Recovery.
What's
Okay,
it?
credit recovery, shush.
Oh my God.
Number 5, go to probability. Okay,
It is
under probability, I believe there's something that says combination, doesn't it?
Where?
I don't see.
Oh, probabilities?
Hold on.
Yes, number 3.
I know, hold on.
I don't
Menu,
I haven't
probability.
Nope, nope,
It
nope.
literally says combination
I don't
number
see
3.
combination.
And it says NCR.
Okay, put in your N, so this case it'd be how many trials?
No, 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 no.
5,
No,
put a
no, no.
comma, the comma is down at the very bottom under pi, and then put your number of successes,
4.
Right on this one.
which is what?
4.
4. Enter.
Wait, I
Oh, there's my 5.
say it one more time.
Wow.
5 comma 4. Okay,
This
because remember my number of trials was what? 5. What was my number of successes we wanted? 4.
Trial.
And so, that's how we get those 5 ways, okay? It's a combination. Bottom near pi. Alright, you want an easier way though?
Yes.
Sure, yeah.
Go to menu for me. Go to probability again.
Okay.
This time go to distributions, number 5.
Alright.
Does anyone see anything if you scroll down?
Binomial.
Oh, there's a binomial option. Go to A, binomial PDF. I'll explain.
Let's see.
Just hit the numbers.
Now
That's
you
not what
should be-
Okay, now we are using PDFs. We use PDFs with discrete sometimes. So notice when you hit binomial PDF, how many trials do we have?
5.
5. What's the probability of success?
0.7.
0.7. How many successes do we want for X?
4.
Type that at 4 in.
What if we don't put
Enter.
X? It says optional.
Man, that's so light. I love this. I love this.
Man, look at that number right there. Okay, so if you do not hit the, this is what it'll do. Menu, probability. Now tomorrow we're going to heavily talk about how to recognize when it's binomial, because that's what you really have to recognize. So it does say optional. Notice right here, Braden, how it gives you lots of these.
Yeah.
So this is 0 successes, 1 success, 2 successes, 3, 4, and 5 successes. So it gives you all those probabilities.
Oh, you made
Okay? But we're also going to learn about CDF tomorrow. Okay, so we're going to finish up all of binomial and get into geometric tomorrow.
Peter, this formula is useless for you because you have no successes, okay, buddy?
Man, y'all are
So now, can you just
such
write down your
kind
number
people.
again? I don't think like you're following
Okay.
through.
You know, all this is irrelevant if you're in math too. Because you've got a calculator.
I know, but you have to be able to recognize and I wanted you to understand where it's coming from.
Can you write your number down so I can make the blue chat right?
Mister, can I have a question?
Dude, I could be like the bus. My mom,
Oh, you're taking a bus?
yes, my mom told me to run.
That's why I be out here first every
Yeah,
day.
you're gonna be waiting.
I'm about to be like,
You're gonna be waiting, thank you.
She had to go do a test.
I was gonna talk about the project.
I said today. I said today.
No.
I was saying homework.
I was not. Oh, I know you're not talking.
I talked.
Make sure we catch the bus, okay?
I know you're not talking
Guess
about.
what I was on Friday?
Wait, where were you?
Taco Casa.
You're so real for
And
that.
it was disgusting. But the chips, you know, the chips with the cinnamon sugar, they were good. No, I'm not even kidding.
No, but I want you to think about it. I want you to look it up.
Yeah, nobody's eating a taco casa.
Shut up. No one asked you.
Listen, all I gotta say is Taco Casa was.
Low-key,
I
it's
took
so
Taco
overrated.
Casa until I figured out.
It's not
Taco
Okay,
Bell.
I'm not saying it's like the best food ever. I'm just saying it's good.
See, and I would like Taco Bell more if it wasn't so expensive. I believe they're paying $20.
It's
I still don't like
Oh,
Taco
that's
Bell.
because
There's something
people, it's not that
about
people
it.
regard highly, they already regard it like mid. But even then, it's overrated.
Even as mid is overrated, I'll agree to that.
Like,
Yeah,
I'm not
I'll
even
agree
saying
to that.
The reason
like,
why
I'm not
it's
saying it's, like,
overrated
the
is
best, but I'm
actually-
saying it's good.
Anyway.
Oh my gosh,
It's
you
just
guys
people
ignore me.
put people
Right.
because like, oh, I'm at Taco Casa, then oh, you
I wouldn't, I just
Yeah, I
want to
feel
say
like it's like the name.
Yeah,
Because
it's-
realistically, I don't
no,
think I
it
eat
isn't.
anything. I might get like beef nachos.
It's
but that's
literally
about it.
calculated right there.
Like it's literally at stake.
With
that
what
you
standard
ain't-
deviation?
Yeah, like,
That's low-key nasty.
no, okay. They're not.
No, I need to get to it.
I know, that's what I'm saying,
like
nachos are the only
cheese
redeeming
nachos.
thing.
Yeah.
But nachos are the
Yes.
only redeeming
No,
thing.
Those are good.
But
Like I
if you're
said, this is my
describing it, you
issue.
gotta
This is my
cuss it,
issue.
I still
right?
like the
So
chocolate.
you have to
I like
report a
Taco Bell.
center.
We'll Taco Bell back.
You have to report a
quesadillas
measure
are
of
so
spread.
expensive.
I don't know, this,
Yeah.
I don't know, something about
Like,
Taco Bell just doesn't sit right.
Does it have
I
an
used to
IQR?
hate Taco Bell.
It's probably low-key just that, it takes a lot more work.
Yeah, you
to-
can't.
It does not
even
take
put
that much
files
work
and stuff
for a
in it.
quesadilla.
I'm talking about like they have
Because what it was
and
doing
everything.
was
Just
just
the other things where they can easily just like
2.5
Right,
here
so-
and we have one.
like they can mass make tacos,
So,
so
like,
like they can like mass produce tacos really easily.
Yeah.
So the median
It's
This is our major manager right here.
Well, you're a manager.
Manager.
But
I just use that title to get out
when
of the
you
field.
deal with probability, do standard deviation.
Low-key, okay.
That's it. Okay. So I know that from the future for sure.
Spin it.
Oh gosh, hold on.
You gotta lock in real quick.
It's literally been once. I haven't done this since last semester.
Oh, yeah, and the two,
Yeah.
Oh,
I can't.
tell myself.
Okay, major ed.
Okay.
I can't.
Da-da-da-da-da-da.
They were.
Oh,
Peas.
P
It's one of those quick.
A
Look at it.
T S P A T S.
Go.
Let's
I
go.
promise you, there
Real
is
talk, why do you have those?
He's a manager.
He's a.
He is a
I'm telling
manager.
you, I could do some basic. I could like a one turn.
I want to get